Are you ready?
I'm ready.
Okay, I click on live. So now everything is live. So I just keep talking a little bit before we get into the introduction and stuff like this. We need to make sure that we do have a voice, so anybody in the chat, just check out if you do hear us or anything else. If so, yeah, please comment in the live stream here so that we know if we are live. I can see you, I can hear you. That sounds perfect.
All right.
Okay, all right. So,
Amazing.
welcome to everybody. Welcome to this today's live stream. We do have two guests again here. We are here with Scott and we are here with Jonathan from Decentral. Do you guys want to quickly introduce yourself, or I bet most of the people know who you are, but just for the sake of keeping
Scott, please go
everything up.
first.
Yeah, sure.
Scott?
Hey, okay. Sorry, there's just a little bit of delay on the audio, I think,
Got it.
maybe. But uh, yes. Hey, I'm Scott 9000. I'm sort of the instigator of the Bitaxe project, but now we got a lot of cool people working on the Bitaxe project. So super stoked to have all you here. And yeah,
All right.
well, Jonathan Decentral instigated this particular live stream, but we're gonna try and reverse engineer the some of the Bitmain Antminer serial data protocols using a cool new board that was actually designed by Survapes on the OSMU Discord. It's called the Ant Sniffer, and that's what you see there. Jonathan's got it on his desk, but it's a cool little adapter that goes in line on the hashboard data cable and breaks out all of the pins so that we can connect it up to a logic analyzer and check out what's going on. What miners do you have for us today, Jonathan?
All right. So right now I had the quick at hand. I had the S19, which we don't have still for Bitax, at least that I'm aware of. I can see it as an open source mini bit, or sorry, Bitax. And there's also the S19J Pro, which also, so those are two different type of chips that we don't have so far on the Bitax series. So I figured it might be interesting to still go on relevant machines, right? The 19 series, but that aren't covered right now. So the S19 will have a BM1398 chip, and the Antminer S19J Pro will have a BM1362 chip.
Nice.
Amazing.
Nice. I'm
And
looking forward to seeing these.
basically, with this sniffing process, we're trying to actually get what kind of data or what kind of information.
So essentially, and correct me if I'm wrong, Scott, but the goal here is to listen at how the machine is communicating, right? So we want to have it exactly in its default state and see, like, for instance, when you power it on, what's actually happening inside the wires communicating, for instance, in between the control board and the hash board. So which command exactly, I guess in a signal-wise way, is sent to the hash board to activate the circuit and start hashing, right?
Yep.
For instance.
Yep. Exactly. That's the right idea. So each miner has a different ASIC model number in it, and that's what Jonathan was referring to. So the S19 has the 1398, and each one of these has a slightly different protocol and a slightly different data packets that it sends over serial to communicate with the chip itself. And this isn't documented anywhere. It's pretty hard to come by. So this is what we're going to try and do today is for the first time that I'm aware, try and figure out exactly what the data looks like going to these chips, and we're going to figure it out using an extremely cool tool here. That's the Salier logic analyzer. That's that little red box there. It's a logic analyzer, so it's sort of like a oscilloscope, but for digital signals. So it just shows whether the digital signal it's connected to is high or low, and it's kind of cool because it records it. So you can sort of press record, and it will record the state of the digital signals and then display it on the screen. And we'll get into it, but there's all sorts of cool analyzers that you can do in the Salier software that will decode different protocols and show you actually what the data bytes look like on the screen. So it's an incredibly useful tool. The Salier is probably the Cadillac of these USB logic analyzers. It's not cheap, but it does a really, really good job.
Probably the hardest part will be as soon as we do have a connection and can read out the stuff to actually figure out what it means, right?
Yeah. I've spent a lot of time looking at these, so I'm hoping that we can learn a couple things here right away. But certainly recording this stuff and saving it, and we'll post it online on maybe the OSMU Discord so that everyone can get a look at it. But you're right; it does take some time to sort of study it and figure out what it actually means, because we're just going to see a bunch of seemingly random hexadecimal bytes flow by.
So if you allow me, I'll just do a quick introduction and explain a bit my initiative with this stream. So Decentral we founded in 2016. We started very small. We're essentially pleb miners ourselves. I started with just one Antminer S line in my microwave socket in a small 4.5 apartment. So I learned the hard way, at least back then, that it wouldn't fit on 120 volts outlet and that it was noisy as hell. So that's when we started, to look into facilities, especially because back then centralization was a big thing, especially in China. And we had here in Quebec a big opportunity. Back then there was no moratorium, there was no highs on the industry. So we looked at our rates, we made the maths, everything, and it looked like this is a no-brainer deal. So we started our company. Now, for those that followed a bit the Quebec, all the histories, there was a lot of calling the miners to come in, and then there was like a moratorium put in place. Those that managed to get a grandfather clause managed to keep their facilities. We weren't one of them because we were under an expansion. So we managed to essentially buy that from another company that had this grandfather clause, get our mining facility going this way, strip the first one, and proceed this way. Then in 2020, we essentially started to look into doing our own ASIC repairs. Still in 2020, there was like almost no documentation. Bitmain wasn't doing any training. So essentially, I've learned the hard way, and I have no electronics background at all. I've learned the hard way going on Russian forums, Chinese forums, stuff like that, and just good old figuring out. And the demand just got crazy. We got up to 30 employees doing repairs. You can see we now have a pretty decent place. People normally looking at our stream will see us in our class. So this is another location, but it's the same point of service we are normally serving you from. And so yeah, since we are today running full machines, I've brought it in the warehouse so we can actually connect and have the full power so we can make that analysis here. And now, since beginning of 2023, we got very involved into the Bitaxe project. And I'm a big believer that you can contribute to open source, even though if you're not yourself a programmer, or for example, myself, I'm not an electrical engineer, but I'm, learning with everybody, and I'm trying to make sure that each and every one can also contribute in their own way. So that's the goal of that stream here, is to say, look, I have no electrical background. I'm not an electrical engineer. I'm going to be using those tools, and I'm going to be figuring out stuff, live with all of you guys. I don't know more. I never used that tool ever again, ever so far in my life. I've bought it and wanted to use it since forever, always busy on stuff. So unfortunately, couldn't put my head onto it. Working on different other projects like Ashboard tester and everything, and I know this device will be very useful. So to me, it's really important to to learn that, and we got people here at Decentral that can deal with that. But myself, I'm the CEO and founder of Decentral, and every position and every task my employees will do, I also do myself. It's important for me to understand each and every task. So stuff like that, I definitely want to put my hands on. And I thought, well, let's do a live stream and make sure anybody that could also contribute and make the open source Miners United community grow and become more helpful is going to be, is going to be a win for everyone.
That's amazing. That's really amazing. I'd really love to hear this. One thing I need to ask you right away is maybe for also other people that might be interested in, do you offer a hosting service?
Yes, absolutely. We do have hosting in Quebec. Obviously, since we're limited, it has to go either to when we have free spots or when our network of partner facilities, because we do manage some smaller facilities around us, and normally they will let us outsource, let's say, the use our hosting customers at their facility that we manage. There's that in Quebec, and otherwise than that, we're also expanding right now in Alberta. It's also through obviously some partner networks. So it's not a direct hands-on experience like we used to up until now, because normally it was our own facilities. But since now we're constrained, at least for the moment, by the current moratorium in place, it's the way we can offer. But it's very good packages. So definitely, if there's anybody in the audience that want to reach out, we do have access to stranded gas in Alberta. That's decent prices, decent tax rate as well. And the political, even though we have our own issues here in Canada, the political climate and stability is definitely there for mining. So I wouldn't be worried to send my miners here.
Amazing, amazing. All right. So, what are we gonna do now? Like with having the major or the initial process of understanding what we're trying to do with this sniffer today, how do we proceed? Like, I see there are a couple of connectors on this board.
Yeah.
What are we doing?
So maybe and Skot obviously is gonna assist us in going the right way, but we can start with this machine here, and obviously maybe even do a small inspection of the machines, because I guess a lot of people in the audience don't necessarily have the chance to play with and see hardware. So let's have a quick look first. So this, if I'm not mistaken, here should be the Antminer S19J Pro. So you have the machine right there. So this being the control board, so this is essentially the brain of the operation. This is where you have your web dashboard. So this is the equivalent, if you want to compare it to a Bitaxe, let's say, because our audience is very familiar with Bitaxe. This is the ESP32 chip, essentially. So it's the part that sends the work to the dashboard. At least in the 19 series and 17 series. Now I know there's some different stuff going on with the S19 XP, but up until then it was the control board sending the job to the chips on the dashboards, which are here. You can see those bus bar here. So those are the power supplied by the power supply that's just right here. So this is the APW12. Let's remove this one. Let's go. So this is the APW12 power supply. This one is can only work on 220 and 240. So this is an issue mostly for North American miners, but not really for European miners. And I'll do a quick plug for Pivotal Pleb Low-Key Kit at the same time, which allows you to use an APW3 or APW9, which both work on 110 on your S19. Obviously, you do have to keep your wattage low for your power supply and your breakers. So that being said, we have the control board that's the equivalent of the ESP, and the dashboards that's the equivalent of a container, if we want, of the rest of the Bitaxe. So it's the container of the ASIC chips themselves. I believe I could show you an actual dashboard. I just have to see if I have one handy. Otherwise, I'll just go upstairs and pick one. And yeah, so that's essentially
maybe we can do this later, yeah.
So here, let me bring that camera up. Do we have it? Should have brought double face tape. Let's move the machine instead. All right. So these are the I/O cables, I/O port here, and you can quickly recognize here our Antminer sniffer. So what we'll do is we'll connect here. And then we'll need another wire to essentially connect to the dashboard and keep the exact same communication going on. So all the signal that we were talking about previously will be going through that board. We'll be able to connect those pins here and essentially listen and capture to what's going on. So with that said, I do realize I didn't bring my charger for my laptop. So if you guys allow me for 2 minutes, I'll go grab that. Maybe grab an dashboard also as a demonstration, and we can get started.
Yeah, all right. Sounds good.
Sounds
Sounds good. So that's perfect. So interesting. So Scott, do you know how Sir got up with this idea, or do you know anything about this sniffer? Like it's brand new.
I was kind of surprised. He was just like, "Hey, I put this thing together," and I was like, "Oh my gosh, this is genius!" I've done a lot of this before, and I like carefully strip off some of the insulation on some of those pink data cables there, and like try and like put my little logic analyzer clips like on the wires directly, and they always fall off, and it's actually kind of terrible. And then he just Sir Vapes was like, I just made this thing. And I was like, oh my gosh, that's fantastic. And I ordered one right away. Because and then Jonathan just messaged me and was like, hey, I've made one too. Let's do this. Let's try it out. So I don't know a lot about it. I know that Sir Vapes knows a lot about how this works. So I trust that he's put it together correctly, or designed it correctly for that matter.
Yeah, probably. I mean, like, I hope that we do see any useful information today. Having this for the first time, or actually sniffing to what's going on between the hashboard and the data unit, or the brain of the operation. The what do they call this? The hashboard? No, it's not the hashboard. It's the
control board.
The control board. That's the word I was searching for. Yeah, like having an understanding or any idea what's going on between those two boards would be major helpful to the overall contribution to the project, I believe.
Yes, definitely. I mean, like I was saying before, all the miners have a slightly different protocol, a slightly different data sent over it, and I have never looked at a JPro before, so this will be very interesting to see how it works. We can get some insight into how this miner works, which should be very exciting. It's interesting, the chips in the J Pro are they're really cheap, so the potential for a sort of cheaper, maybe somewhat low end Bitaxe is there if we understand these J Pro chips, the 1362s.
Just a sec there.
Ooh, we got a hashboard. Nice.
Ouais, ce serait parfait ça. All right, so let me unscrew this one so you can see. And I do have a fun fact about the hashboard, but let's see if somebody catch on it before.
Those major heat sinks are insane. They're screwed on, I believe, right?
So the 19 series, the heat sinks are screwed on. Yes, correct.
Yeah. And
Like
one
so?
of the other ones, they were glued on it, I believe, and you can actually rip off the ASICs if you would put off the heat sinks.
Correct. So you do have the, and I can show you, I do have those boards here. So this is the very traditional Antminer S9, and I believe this is where it all started for Skot with the Bitaxe project, with the BM1387 chip. So those heat sinks are indeed glued on the hashboard. You also have the 17 series, which is a different beast. For instance,
Yeah, those ones are glued on, right?
no, those ones, well, so you have some Chinese that would fix those hashboards by using silicon, which is an insanely bad idea. But normally they're soldered on. Yeah.
Insane. You can basically just get them off with enough heat, right?
Correct. Yeah, and that's fine. The problem the 17 series had, and it was famous for, is the top of the chips of the. So it's a copper chip, right? And the top of the copper chip was so little tinned, like not even a grain of rice of tin when it was delivered new. And obviously, what would happen? And I'm not sure the exact chemical reaction that's happening, but the copper will essentially peel off from the chip, and so obviously any tin that's attached to it will peel with it, and the heat sinks would fall, and those chips would be rendered useless essentially, and that's all due to a manufacturing, a bad manufacturing process in my opinion. But the chips themselves, they're very good. So I think a lot of people they became allergic to 17 series, but there's the sick boards, but there's like some very, very healthy boards, and those machines are, in my mind, they're incredibly efficient. So I think it's definitely, for the price they're going on, it's an insane purchase. That being said, we do have the S19 here. This is the BM1398 chip. And the fun fact I wanted to share, maybe you can see, but there is no label on this board, and there's a reason why this is because this one is a clone. So this is a clone of S19 board that was provided to me by someone, obviously I won't mention. But
Okay,
just
so this one is
Whoa.
not manufactured.
Whoa, a
yes,
clone? Like it's not
yes,
made by Bitmain.
correct. So they do exist.
Interesting.
And so it was brought to me by someone that came to Canada and that wanted to meet us and show that it's possible. And so, and I've learned a lot. See, for instance, the silicon process, the silicon making process. So I would always think that some batches were better than other, that they had some, different quality when we talk about the ASIC lottery. But really, the ASIC lottery is more about the position on the wafer. So what I've learned is the chips that are on the edge of the wafer are the less efficient chips, and the chips that are, more in the center of the wafer are the like perfect chips. So like there's going to be some chips that are discarded right on the edge of each wafers, and some people can put their hands on those chips, and what I believe is happening is they'll build those clones with those chips that are normally discarded.
Interesting.
Yeah.
Interesting. That's really crazy. I mean, how that whole wafer works is kind of mind-blowing.
So that's one share I wanted to make, and the other one, this is an S19 XP board. So this is the chips that are powering your Bitaxe 1366. And one interesting fact, again, is that Decentral never bought a S19 XP until recently, and the only reason we bought S19 XP is to strip the chips, so to make Bitaxe. So that being said, we can
But you
proceed.
just purchased the boards and not the whole unit, right?
No, about the unit, it's still cheaper than just buying the chip.
Yeah. Okay. Interesting.
Yeah. Well,
So,
whenever you're doing, scale or volume, it's going to be better to buy the whole thing and strip the chips yourself than, buying the chips individually. That people, there are new chips and everything, so you can have the exact same chip in the exact same condition, but just take it out yourself and save like 50% of the price of the chip.
that's genius. That's amazing. And you guys are doing that just for the bit axes?
Well, yeah, the only reason we're stripping XP chips is either so traditionally it would be to fix other dashboards, but now it's
Okay.
it's also to make the Bitaxe.
That's so cool.
All right, so that should hold in place better now. So again, it's the first time I've even connected this to my laptop. I've launched the software for the first time as well. I don't know if the audience can see it properly. It's in the middle screen on the right of the screen. If we need to, I can. I just need to make the setup, but I can swap the screens, sometimes. So if it's requested,
Yeah, I believe as soon as we do have a proper connection and we do see some live logs or anything, we should switch over. I believe this is not readable at the moment.
Yeah, I figured. Okay, perfect. So let's say we have, I believe we have everything we need. So we have connected here our, so let's bring that back to the screen. So we have connected our Antminer sniffer here. So you can see it's now acting as a man in the middle between the control board and the dashboard. So, and I do believe, because I made some research, but it's really, again, I never played with. So I do believe the signal we need to capture now is going to be the SCL and SDA. Is that correct, Scott?
Actually, so there's two different protocols. There's the SCL and SDA, which is the I2C, and that's going to be talking to the temperature sensors on your hash board. That would be interesting to look at, but that it's not useful for the Bitaxe because we don't necessarily have the same temperature sensors.
So in our case,
maybe let's do the serial pins.
So the serial. So here that would be a TX and RX. Is that it?
That's right. Yes.
Yep.
All right. And so again, first time using that device here, and I'm sure anyways, some other people will have that question in the audience. So I can see here there's some digits, and there's some that should be the ground. You've mentioned connecting, soldering to the ground of our Antminer sniffer, which is not done right now. So we'll be able to go and proceed with that. So that would be the ground right here, if people can
Yes,
see it
that's right. So
properly.
all the G's are for ground, and there's one ground wire for each one of the signal wires, and the signal wires have numbers. One of the cool things about this Cellier is that the colors of the wires also show up in the app. So you can, if you want, you can just pay attention to what colors you connect where.
Got it.
But the idea is going to be you're going to want to take one of those ground wires, the black ones from the Cellier, and connect it to that pad on your ant sniffer.
Got it. So let me remove those gloves for a moment. What I'll do is I'll again quickly disappear. We'll just go and solder one of those wires to the ground. And I'm not mistaken, I just need to have one ground connected, right? I do not need to connect both the TX and RX.
That's correct. Yes.
All right. So let me just a moment. I'll be right back.
Okay. I sent Sir Vapes a pull request with the ground signal, or the ground also connected as a pin. So
I do understand this right. You need to have a separate ground for each connection wire that you're trying to sniff on.
You don't actually. I mean, if you're very, very worried about signal integrity, like you're in a noisy environment or you're doing high speed stuff, it can be helpful to have a ground wire for each signal, but it's not strictly necessary. I think we'll be fine with just one ground wire for the two signals we're looking at.
I'm still a little bit blown away by the fact that he just mentioned there's someone who copied the S19XP board.
Yes, so am I. That's actually blowing my mind.
It's like, yeah, there's someone who's doing this. Like, the heck, why do we not know about this? It's insane.
That is insane.
I'm really curious what we will see today. Do you expect anything major?
So, one of the things, and I don't know if we're going to be able to tell this live or not, but one of the things I'm very curious about is, do the S19J Pros roll anything besides nonce? And so, to explain that a little bit, miners, basically what they do is they do SHA-256 on a Bitcoin block header over and over. But the key there is that you need to change something in the block header before you do the next hash. And so there's a thing called nonce, which is specifically made to be changed for each hash. So the miners, in the silicon on the ASIC, they just increment nonce by one and then do another hash, and then increment nonce by one and then do another hash. And that's actually pretty common. And so the problem is, now that we're sort of in the future and miners are doing terahash, they can actually go through the entire 32-bit nonce space incredibly quickly. That's billions of nonces. But it can go through that in milliseconds, right? Because it's doing trillions of hashes a second. It's kind of wild to think about. So there's a new technique in miners where they can also change more than just the nonce. They have more bits in the block header that they can change to give you a little bit more time before you need to send an entirely new block header to miner to work on. So I know that the XP, for example, it rolls the version bits in the block header in addition to the nonce.
Okay.
The S17, for example, does not do this. So I'm not exactly clear where Bitmain changed it. Was it in the XP, or was it in the J Pro? Was it in the S19 Pro? So it'll be very interesting to take a look at this and see. We should be able to see pretty quickly if it's doing anything, if it's doing version rolling, just by how fast new work gets sent out over the serial port. So, okay, I'm seeing, it looks like you got a ground pin soldered on there. Very
Correct.
nice.
Yeah.
And you've got the one of the Salier logic analyzer ground wires connected to that.
Yeah.
And then you have I think you have do you have the black and the orange?
So I went
Connected
with
to
the
the,
red and orange so we can see well on the stream. That's being connected to our TX and RX. And I do have one of our ground wires connected here and soldered to the ground pad of the sniffer.
perfect.
So next
And I
step
suggest some
would be,
care
I
on the sniffing.
guess, to launch our software.
So our friend Crypto Ice has a very good point there. You don't want to have any of those wires touch the power bus bars on your miner. So just
Yeah, for sure.
set that up in some way so it doesn't fall over and cause a
So you mean
sad.
any of those terminals? Yeah, I do understand. Let's just make a quick loop out of this one.
There's there's somewhere between 12 and like 15 volts going on those things. So it's not going to be like fire, but it certainly wouldn't be ideal. The data pins probably are not rated for
Let's just
15 volts
as
or
a,
whatever.
all right.
Nice. Okay, that's looking better.
Yeah, way better. And he's also suggesting to use some tape, but I think like having it hanging off the side is also fine.
Yeah,
Shouldn't
but
interfere too much or at all.
I think this way shouldn't be a problem.
All right.
All right, so we did bring some power here.
All right,
And
kids, don't try this at home. We're professionals. No,
No,
wait, do try it at home.
But never ever touch the bus bars when this thing is running.
Absolutely not, no. So 3000 watts going through that power supply. One more question before we proceed. I believe Skot will need some network on that machine, right? Because we need to have work being done by the miner.
Yeah, it needs to create or actually send the block headers and the information to the hash boards, I believe. Otherwise, we don't see anything.
That's right. That's right. Yeah. Hook it up as you would normally.
Okay, so this can be loud. I'm not sure if we're gonna be able to hear Jonathan then. I hope that we're gonna be able to.
A good occasion to show our kit here. So we do have those PixLink Wi-Fi adapters that we connect to a converter, then to our 6-pin connectors, and it allows us directly to come and take it from the power supply. So I'll
Whoa, what is this thing? I've never seen this before.
No, it's custom made. So essentially,
What is this?
oh, let me see. This one is the version for S9, I think. Just a moment. No, it's me done being stupid. This one here. And this one here. So let's show you a bit. So essentially, we have a 6-pin splitter. This 6-pin splitter, we essentially here strip, the 8-pin connector, bring it to the positive negative of that converter. So we have 12 volt becoming 5. And then we just connect it to the right polarity on that wire. And instead of being a splitter, it becomes, it essentially allows you to have your Wi-Fi directly powered by the power supply and still being able to power your control board. So it's like the Sniffer, but with Wi-Fi.
Interesting.
Okay, so you're going to plug that Ethernet into the control board.
Correct, yes.
So I believe you're just doing this because you don't have any Ethernet cable laying around that is long enough?
Oh, well, yeah, I could probably find and unroll and bring it, but it's just going to be faster to connect by Wi-Fi. So we'll just need to set it up quick. So launching the beast.
I'm sure it's already set on public pool, of course, everyone's favorite solo mining pool.
Yeah, if you don't know about this pool, let me post something about this. It's ready. That's the pool that you guys should mine to. I posted it in the live chat. This is the pool that you guys need to put all your miners on. We want to find the first block with this pool. It's absolutely a must that we need to do this.
So if we find a block right now, while we're recording on the Salier, this is going to be it's going to be. I feel it. It's going to happen. We're going to see that golden nonce come by on the logic analyzer.
I'm wondering if Antminer is actually putting some Easter eggs in their boards. How cool would this be? It's probably, yeah.
It won't be long, guys. I'm coming back. I'm setting up the Wi-Fi.
Okay.
All right.
Yeah, it's not a very exciting Easter egg, but each miner does send its model or the chip model number in hex through over the serial port, which is kind of exciting. That's sort of like the first proof of life that you get when you're trying to talk to a chip, is it sends you back its model number in hex, which is, I don't know. It's exciting to see, especially when you've been banging on it for a long time and it hasn't been working.
I bet so. So okay, having this kind of Wi-Fi dongle, it looks sick, but it's kind of nice. Like I've never seen something like this. I would never use Wi-Fi on my miner anyway. Like with the Bitaxe, it's fine, but with such a big machine like an Antminer S19, I would rather use Ethernet, probably.
Yeah, but imagine you're using the miner as a heat source. The reason we thought about the Wi-Fi repeater mostly is because of the miners being used as a heat source. So imagine you have a warehouse, or a lot of people will have their commercial buildings, and then they want to heat some other building that they're using sometimes outside. Here in Quebec, you have at least like 8 months of wasted heat. So if you can plug a miner instead and bring in some revenue, that makes sense.
Yeah, absolutely. Like there's space heaters and stuff like this. How they're nowadays called. That's an amazing thing, and of course, like this Wi-Fi dongle has its position of being there, and I really loved it. You do such a thing. It's amazing.
Well, if you want to review it, I can arrange that and get you one.
I don't have any Antminer. All Antminers that I do have are hosted somewhere in the US.
Yeah, it
the
makes
electricity
sense
prices here in Germany,
yeah.
it's not payable. I do have like 35 cents per kilowatt hour. I do run like 5 Bitaxes that I do have right now here at home, and I do run some cloud stuff, but it's all I can do otherwise, or no, my wife would kill me with this electricity bill.
So I was just going to say that I think a Bitaxe and an S19 send the same amount of network traffic. Maybe Ben can correct me if I'm wrong, but I think that they send the same amount of network traffic.
Well, I was curious about that one, and I certainly wish Ben clarifies that for us, because in a certain sense, there is more work being sent by the miners. So necessarily, they're like, in my mind, there should be like more stratum tasks being sent and exchanged between the pool and the miner. So that should result in more traffic. But I'm really not sure.
Yeah, but Ben is correct. Ben is saying that's correct. So it's the same traffic. I do believe like we do see those lower values or those lower difficulties that we do share with the pools. So we actually do have a high amount of traffic. And
so the overstratum, the miner, and the stratum pool will negotiate the difficulty. So there's a little bit of traffic in the beginning where they pick a difficulty, and usually that's based on what the hash power of your miner is. But the idea is they're going to pick a difficulty that makes it so that there's, roughly traffic, like stratum packets going by every, second or so. Yeah, there you go. So that's what Ben says. The difficulty is so that all miners submit work at the same rate. And the other thing is interesting is stratum it contains what are called block templates. Well, it's a form of block templates, but each stratum packet contains a ton of work, like an absurd amount of work. And then the control board job is to take that stratum work and generate work for the ASICs from it. But, okay, so Ben's saying it sends every 5 seconds, but you could go a lot longer than that because there's tons of work. There's literally tons of work in each stratum packet. So, if you have a miner that's running at 100 terahash, the control board can generate enough work for it based on its stratum packets. But the same thing would happen with the Bitaxe, just, it's half of a terahash. I don't know if I explained that exactly right, but yeah, I think that's right. So using Wi-Fi on a Bitaxe is basically just as risky as using Wi-Fi on a S19, 200 terahash miner. And it's not going to add much latency. If your Wi-Fi network is configured properly, it's going to add like a negligible amount of latency.
Yeah, and it's clarifying the submitting work averaging at every 5 seconds and new work every 60 seconds. I'm wondering, like, at what point do we actually increase the capability of the processing unit? Like in the Bitaxe, we currently just do have an ESP32S3, and this one has 2 CPU cores in it, and it can do more, I believe. But I'm wondering, at what point do we need to have another like head of the unit?
So yeah, I mean that's a good question, and we've talked about this a lot. One of there's a couple places for bottlenecks. One is generating the work and actually sending it out over the serial port. So if you were to do a miner with the 1397 chip out of the S17, we actually, think the limit is that the ESP32 can control. The limit is 10 chips, right? And then you would need a better serial port and probably a faster processor to deal with that. But like I mentioned before, the 1366, the chip out of the XP, does version rolling, and so it's a lot less taxing on the CPU in the control board to generate work because a lot of the work gets generated in the ASIC itself. So, we haven't actually tested this, but my hand wavy answer is that we could easily control 100 XP chips with an ESP32, judging by how much more efficient it is at generating work. So, 100 XP chips, that's getting close to doing a full XP hash board from an ESP32. But, obviously the XP has 3 hash boards, so could you control a whole XP with an ESP32? I don't know, probably not. That's pushing it. And there's a few other things that the control board has to do. It has to verify the responses back, and it has to deal with stratum and all those things. So the CPU would probably be pretty taxed in that case. So to answer your question, it's largely untested, but once we start getting up to doing these, triple digit terahash or miners, the ESP32 is probably not going to cut it. You need to start getting into these gigahertz, multiple core application processors that are on these control boards that are running Linux.
Almost there, guys. Waiting for the nth miner. The Wi-Fi is on.
All right. Do you actually have a connection to it? Is it running?
Yeah, so the Wi-Fi, I can see it. I'm waiting for the nth miner to come and show up.
Oh, all right. Probably now screaming in his warehouse. All his employees are fleeing. Like, those things get so freaking loud. It's insane.
They do. Fans is an understatement. They're like, they're like screaming jet engines.
Funny thing, back in the days, while the S9 was still a thing, I had a fish tank filled with mineral oil, and I pushed in my S9 in it just to make it quiet, and I hooked it up onto the bed while I was still at my parents'. And yeah, that was silent. Nobody noticed it until the electric bill came up.
Did it stayed cool though?
Yeah, it did. It did. What I used was I used a fish tank pump and a radiator, like a 3x3 120 mil radiator, and I hooked up like 5 fans to it, all on 12 volts. Perfectly easy.
And those fans were quieter than the.
Yeah, of course. Like spinning 12 fans on those 120 mils at like, what was it, 4,000 RPM? Not that much.
Nice. Okay, I'm
Very,
glad you
very
had
silent.
some like radiator and some circulation on that fluid.
It,
Seems
it
like if you
was
just put it in
quite.
a fish tank, it would overheat pretty quickly.
Oh yeah, I believe so. I believe so. Maybe the dissipation of the heat could cool it, but then you would probably underclock it. Those S9 chips are really inefficient compared to the newer ones that we do have today. But back in the days, it was quite nice, and experimenting with it and getting used to all this stuff, how this works, how you can actually like doing this even with minor or smaller electronics. Like imagine we do have someone in the community who is doing this immersion Bitaxe thingy, and he pushed his Bitaxe to do over 1 tera hash on one single Bitaxe. So that's really insane. And
That
he
is
put
that
in,
is insane. My mind is blown once again that worked, and it seemed to be, it wasn't just a fluke. It seemed sustainable. He was
yeah,
getting.
it was stable over 24 hours. He ran it, no issues, everything was fine. So that was really insane. I believe it was Crypto Eyes. Correct me if I'm mistaken.
Yeah, it was Crypto Ice.
So,
He
so
was in
many
our chat here. I don't know if he's
names
still
are
here, but
floating around, and yeah, just like getting the idea of putting an electronic in a fish tank or a small tank and just pouring over some oil and then plugging it into the wall. The first time experiencing something like this is absolutely insane. Like you're questioning yourself.
yes, that's like everything you learned in school is like, do not plug things
Yeah,
in
yeah,
with water.
yeah. I do imagine it like it would be yesterday. Insane.
All right, so I believe we only need to reboot the unit because it's hashing now, but I have the DHCP server enabled, which you should not have when you already have a server on,
Hmm. Oh,
obviously.
all right. So we
So
will
I believe
see in
it's,
just a second what's going
yeah.
on. Um, I believe as soon as we do have a connection and you can find it, we will also see a change on your screen.
Absolutely, yeah. So I'm actually on another computer, not to cut the connection on the Wi-Fi from my laptop, so we can keep the
Yeah.
stream. So I'll be right back. But what you're seeing should be the live feed of the unit launching.
Let's see. So for the viewers that are questioning what we're doing here, so we are trying to actually sniff a little bit of the communication between the control board and the hash boards that you do have in those big Bitcoin ASIC miners, like this one that we do have here. It's an S19 XP or J Pro. It's
J
JPro,
Pro, I
yeah.
think. Yeah.
it's a J Pro. Okay, I'm sorry. Yeah, so we're trying to sniff this. What this means is we're trying to see what kind of communication is going on between the hash board and this control unit. And why are we doing this? Basically to figure out how we can, well, how we can figure out to communicate with those ASICs. I would also say to get a better understanding on how we can proceed with the current Bitaxe project. Like currently, we only do have one ASIC on this PCB, and what we want to achieve in the future is to have multiple in series, like you do see on those big hash boards. And Scott, correct me if I'm wrong, but I believe that currently we do not have the knowledge on how to do this.
Well, we have some idea, but we haven't finished it yet. So it's in progress. But understanding just more about how these machines work and the subtle differences between the different models is incredibly useful. And I don't have the means to go out there and buy all of the different machines to test them. So having this knowledge out there so that people like Jonathan can he has got a lot of machines, but people like that can go and get this data and help in the effort to reverse engineer all the various models. I think is huge, so that people can repair them, people can modify them, people can improve them.
It's absolutely insane. Just need to appreciate this here in this live stream. Like, Jonathan has his own company and he's doing ASIC repairs, and he's still contributing to an open source community to get things more in the hands of the people.
Yeah, look at all those boards in the background there. All that stuff is stuff they're working on repairing and fixing and upgrading for their customers and stuff. And to do all that, to like figure out what's wrong with these boards, and like he was saying, completely learn the hard way, right? Because these things do not have a lot of documentation. And so anyone who's going in there and attempting to repair them can benefit from a better understanding of how they actually work.
Yeah, the funny is that's how reverse engineering looks like, kinda.
All right, so sorry for that, guys. I can see my my device, but I guess there's something I haven't set up properly. Okay, we'll leave it. I'll just find another wire just in case as a redundancy. Let me... Nick, peux-tu m'amener un fil réseau voix avec Gab? Un fil réseau qui va partir de ta showroom jusqu'à ici.
Okay. No worries, no worries. We're doing this live here.
Yeah.
Yeah, we're just bearing with you. Could be a little bit boring at some point, but I mean, it is what it is, and we're trying to figure this out together, and getting this to the people live is be insane.
That's why we call it hardware. It's because it's hard.
Yeah.
So another project that we're working on over at OSMU is it's called the bit cart, and it's a replacement control board. So that that green board that you see there with all the data cables connected to it, it's going to be a replacement for that. So what we learn here today will be also useful in developing that firmware.
All right, so we have it. Let me just bring it to the interface so our viewers can see as well. So let's open up a Firefox session.
By the way, guys, if you haven't done so, leave a thumb up and like this stream. Also, not only on my channel, hop over to Decentral Tech channel and do the same over there. He's also live streaming this on his channel.
So let's also keep in mind this is a unit I haven't tested yet, so it's possible we find some issues on it. The hash rate seems low, but it's possible it's also just set this way. Oh no, it's coming up. All right, got it. So you can see, and let's bring that to the screen so people can see too.
Yeah, that's what I was asking about, like change the screen so that we can see what you're doing there.
So this is for those of you that never saw, this is essentially a Antminer S19J Pro interface. It's a bit different than the previous models Bitmain did. They have that new interface still running a CJ Miner, which by the way is open source as well, and Bitmain is releasing some modified version of that software without releasing the source code. That being said, it's the first time I'm streaming from the storage room, so there's still some learning curve about how to set up this one where we don't have the interface now. Ah, there you go. Okay, I understand. So I did try to zoom out so you guys could see more of the screen, but it seems the interface won't take it. So yeah, this is the interface.
Right,
Let
it's
me bring back the
loading
mouse. So you have the
slowly.
real-time hash rate here. I can't hardly hear you guys also, so I'll just go ahead and present the dashboard, and then we can see what's next. So you have your runtime. Here you have us running on solo, so we should point that to Ben's pool. And you have the fan speed of each of the fans, your chip temperature in the intake and the outtake. So here you have your PCB, and here your chips. The frequency is being set on. So a lot of people will ask the Bitaxe, frequency to set. Well, each machine will have their different settings. Some will come at 545, some others will come, let's say, at 555. So it's really about finding the sweet spot for that batch of chip. On the machines, there are normally there's a concept we call bins. So they're not normally going to be tagged and put in between, not in between, but batched together as bin 1, bin 2, bin 3, bin 4. And so bin 1, for instance, is going to be a particular batch that, for instance, runs at 90 terahash. Running at 90 terahash is going to be maybe a bit more voltage, a bit less frequency. So for the chips that have, let's say, a bit less potency, they're going to require a bit more voltage. They're a bit less perfect, and they're going to request less hash rate of the chips, and so it's going to run stable. So that's why sometimes you'll run aftermarket software like Brains or whatever, and instead of just applying one setting to the whole dashboard, it will try to figure out domain by domain which frequency it could run on, and it's a bit of a gaming, and it's something also I wish, and I do think that putting our hands on this right now will help us understand is also the firmware part of those miners, because that's another big part that's closed right now that we want to open up, especially when you think of things like Endbleed. I believe that was back in 2018, where Bitmain essentially embedded something that could allow them to remotely kill essentially the miners. And obviously, when you have those machines running about 70% of the network hash rate, you don't want any exploit or vulnerability on these machines. So for me, having a diversity and auditable code that you run on those machines is like it's a matter of survival for Bitcoin.
Yeah, definitely. Like I've been talking about this a couple of weeks ago. I was invited by a Bitcoin hotel here in Germany, and I talked about the decentral factor that we do have with Bitcoin. And what you talked about here is really important. Like, how could we even trust any company if you do not know what's going on in the background? Like with the OSMU, we try to publish everything on GitHub or in the community on Discord. So we will give all the information that we do have to everybody. We will not hide anything, so you can trust all the things. So trust is the major factor that we do have here, and it's really important that we find out more about the machines, and it's really important what you said there.
Yes, I totally agree. I mean, it's the ethos of Bitcoin is, that decentralized factor and sort of like not having to trust anyone, right? Like you don't have some secret somewhere in some centralized organization that you just have to trust that they're doing the right thing. No, it's like the whole ethos of Bitcoin is that it's all out there and we can see, right? Don't trust, verify.
So I'm gonna put myself some earplugs so I can hear you guys while speaking. The good thing is I got bone conductor headphones, so I'll still be able to hear you guys.
Oh, nice.
Oh, all right. Let's hope this works.
Yeah, well, it seems like it's working, so we can go ahead.
All right, that's good.
Yeah. All right. So let's bring back the other screen so you can see what's going on, and we'll go for the next step. All right. So we do have this loud machine running now. We have that board connected. I can see so this one here. Actually, I do not see the diode, and I believe when I tested it once, I would see the diode here being lit up. So I'm not sure if that's a good sign or a bad sign that we don't have it lit up this time. I connected it to a hashboard tester actually the first time I just tried to see if it was passing the signal through. and the
Mm-hmm.
dial would light up. So again, I'm not sure about the fact that it's not being shown here, but it should be working because I mean we have our hashboard here, so we should be able to go and capture our signals anyways. So we'll need to
Yeah,
go.
that's interesting. If if the if you see on the dashboard that all three hashboards are mining,
Yeah,
then I think it's working, right?
yeah,
We know the signals are being passed through there, the ant sniffer, just fine. So um, that's interesting. We'll have to take a look at the LED and see what's going on there. But I think it's working. We should
yeah.
fire up the logic analyzer.
All right. So I do have it on screen. Let me bring that up for you guys. All right. So first
All
time
right.
launching. So welcome to Logic 2. All right. No and no.
So okay, yeah. So sounds good. You can probably just continue past that.
Let's just close the tips. All right. Now I do believe I have to identify the channels we want to listen to, right?
That's right. Yeah. So there you go. That's what it's showing you there.
Would that be?
If you click in the picture of the logic analyzer in the upper left,
Yeah.
I think is where you can pick the channels, I believe.
So can
They're
you
like
say?
right up top there. I think that's it.
Yeah, yeah.
Yeah. Okay.
There's a small delay. Yeah.
Oh yeah. Sorry, there's a delay.
No, no.
So you don't want to enable any analog channels. We're not going to do that. You want to just do digital channels, and you're going to click on the orange and the red because I believe that's what you have hooked up.
Correct. Yeah. So no, that one, this one, and this one. So we remove zero here. Right. All right. And we'd also, I guess, uncheck the analog.
Yeah, that's right. Right. We're going to undo the analog. You can, yeah, you don't want zero either. Okay.
So
And
what's the
click on
meaning?
both the,
Yeah, go ahead.
okay, you got it. You got it. Sorry, there's just a little bit of delay on
Yeah,
that.
yeah,
But
yeah.
yeah, so yeah, set the sampling frequency there to the highest number, to the fastest setting for this.
Is that the equivalent of the baud rate?
Yeah, I mean, you want to do it as fast as possible. There's no reason to go any slower.
And am I correct saying that this would be the equivalent of the baud rate?
Well, we want to determine what the baud rate is, so I would set it to 100.
So, oh yeah, yeah, I got it. So yeah, uh, this one here.
And set it to 100 megasamples per second.
Yeah, just did give it some time and it's gonna show.
Is it automatically adjusting and automatically trying to read the data? And by the way, are we now connected to RX and TX?
Yes, we are.
Or
So, and
did you swap them?
let me give you the exact read. So right now we have the orange wire on the see, let me just change at the same time. I was on RST. So here, RX is the orange wire and the TX is the red wire.
All right.
Okay, so you can close out of that screen there. The device information screen.
And then we can press the start button, I believe.
Yep.
So we just start right away.
So if the miner is running, then you should just be able to click the start button, and we should see those bits go by.
Boom. You guys should
If we
see it
did it.
soon enough.
Yeah, there's some delay on the stream, so.
Yeah, that's normal.
All right, we're seeing it now. This is cool. So, all of those little lines are bytes. Well, actually, they're bits. But if you We can you can probably stop it now.
All right, give it some time.
And you know, I think it's going to be repeating itself right now because the miner's just running and we're not changing anything. So you can stop it there. And so now go to one of those sort of vertical lines on the orange channel and use your mouse scroll wheel to zoom in on it.
Right. So zooming in now, you guys should see it soon enough. And you can see it's also separated, so between the bits that are sent, I believe it's trying to maybe bunch them together as bytes.
This is so cool. This is so cool. So you can see, yeah, there's actually quite a bit of time in between the bytes that are being sent out. But if you keep zooming in on that, we'll see actually the bits that form these bytes, and there's going to be a lot.
Yeah, so it's exactly the same as looking at an oscilloscope, like you mentioned when we started. Yeah.
So if you hover over one of those periods, one of the short periods, it'll calculate the frequency for you in kind of the tooltip that pops up there. And that actually is very close to the baud rate.
Got it. Yeah, I can see.
So yeah, I think it's like 3.125 megahertz. That's 3.125 megabaud roughly. So the thing to do here now, if you want to go and look at, there should be the same thing on the red channel, which is your control board TX, but that's the work going from the control board to the hash board, and you should be able to see much less frequently, but it's sending work out to the hash board.
Yeah, so I did have to zoom out quite a bit to finally see a red line, but I can see now, so it should pop on your screen soon enough.
Probably every 5 seconds or so.
Yeah. So, yeah, the red is packets of work going out to the hash boards, and the yellow is the responses back from the hash boards. So let's set up a analyzer on that data, right? Because if you look at it now, it's kind of just like, okay, great, there's a bunch of like bits there. But one of the things that these analyzers can do is look at those bits and actually decode them into hexadecimal bytes, and we can get a better idea of what data is being sent out. So if you go over, you have the window open, it says analyzers there. If you go into that analyzers pane and you click on async serial, it should bring up a window where you can configure the analyzer.
Correct. So now it's asking for my input channel. I have both of my channels obviously are enabled, so I should pick one of those, right?
Yeah, exactly. So pick one of them, and then, yeah, we're going to do this for both channels. So you can just pick channel 2 to start with, and then select that. And then the next thing to do is to change the bit rate.
And we're going again to 1 million, right?
I think we're going to do, we're going to do 3 million, the 3.12 megabaud. So 3,125,000.
I had a quick key there. All right, perfect.
3,125,000. There we go. Yeah. Okay. So if you click save,
Done.
then we can look and see if we got it right. Because what we're trying to do is guess the baud rate here.
I see. So now there are like small, let's say, tooltips that are showing up on top of each of those lines. and it's giving me hexadecimal, I believe, results.
Oh man, I think we got lucky. I think we got it right the first time. What you're seeing there is the hexadecimal packet. You can zoom way in on that and we can actually see it. But one of the things I've learned from looking at these things for a while now is that packets start with, that are going from the control board to the hash board, start with
Ah, yeah, that
55
magic. Yeah,
AA.
yeah, I can see it. So that's the magic. I've read about that. The magic, how they call it, magic number that starts like each of the word on the dashboard.
Exactly. Yes. So, oh man, this is so cool. So, yeah, so we got it there. This is pretty cool. So like this is kind of where you want to be. And we can see that's actually the data that's being sent, and that represents a work packet. And we've done quite a bit of work to try and figure out what these mean, but essentially there's that. Someone get some tissues. Oh man, yes. Pretty excited over here.
Yeah, that's really amazing. I just grabbed myself a beer, guys. If you want to do so as well, feel free. This is looking
man.
amazing.
It's like 3:00 here, but man, it's that exciting. I need a champagne. Yeah, so the packet starts off with 55 AA, and that's actually, if you look at it, that's just alternating high and low bits. And then we get into the whole protocol there, and then the last byte is a checksum. And so let's see, what do we want to do here? So on the right side, that pane is actually like a list of all the bytes that happen, and so that is pretty exciting. But I think what we want to do next is add another async serial analyzer, and this time do it on channel 3, the other one.
Got it. So in this case, we'll go back to our analyzer screen. Same number, and then we're going to channel 3. Stay here. And so I should see the same going on those packets. And we still have that magic formula, so let me zoom in.
Yep, looks like you got it. Yeah, it's the same process. We should see decoded data appearing on the other channel. This is the response. Okay, and so you can tell you've got it right because on the response, the sort of magic bytes at the beginning are reversed. Instead of 55AA, it's AA55. So that's how you know you've got a valid response coming from the hash board. And these are pretty cool. So these responses here are they're nonces, right? They're nonces that the hashboard has found that are better than the difficulty that the control board has configured the hashboard to do. So one of the things that's pretty interesting here, actually, if you can zoom out, and I want to find the time in between packets on your red channel there. Like how many seconds is it until it sends out new work?
Yeah. So if I hover or in between two lines, it will give me here some numbers. So I'll let them show on screen. Obviously, they're varying between packets. So some are 1.22558,307 seconds. Here I have 900 milliseconds. Just after I have 2.12727 seconds, going like this. So now you should start to see some on your screens.
Yeah, I'm seeing that. Okay, this is pretty interesting. So this shows me that indeed this miner is rolling something besides nonce, because the JPro is, what was it, like how many terahash is the JPro?
JPro, you have the 100 terahash, 104, and yeah, that's it. Yeah.
Okay, so that means that each hash board is doing roughly 30 terahash.
Correct. Yeah.
And so if it were just rolling nonce, you would see those packets on your red channel there.
Got
You
it.
would see those, you would see hundreds of them a second because it needs to send out work so
I
often.
understand.
And the fact that we see multiple seconds in between work packets going out, that means it's definitely rolling something else besides nonce. And I think it's probably version. But this is cool. I mean, I don't know if you remember, Jonathan, but I think I asked you this a long time ago. Like, what is the J Pro doing? Like, and so this is the answer to that question, which is really, really freaking cool for me to see that. Because now we know that these chips roll version as well, like the XP chips do, and we could control lots of them from an ESP32.
Amazing. First of all, I'm super grateful that you're taking both the time to go through this with me, and I really truly believe it's going to be good knowledge for all of us to push all our projects even further.
So there's yeah, Johnny's saying try and find a nonce frame there. I think all the yellow ones are nonce frames. Or sorry, the orange ones.
So there's one thing I know. There's one of the members of Open Source Miners United who created like some kind of decoding, I don't know, file that you can use with the Salsa logic analyzer. I'm not sure what they use for that file. Maybe you know, maybe maybe it rings a bell what I'm talking about. I'm not too sure what I'm talking about, so I have a hard time, describing it. But I remember seeing, when I was reading through all the documentation about Bitaxe, that specific file that would allow you to be used paired with your logic analyzer and try to decode. So what is it trying to decode? Why aren't we using that file right now?
So okay, wait. So if I understand what you're saying, you're saying, is there a section where it actually decodes what it's doing?
Well, what I meant is someone, and I can't recall the name right now, but I know in
Oh
open
yes,
source.
yes. Okay, I know what you're talking about. Yes. So an OSMU member, who sort of an OG OSMU member, um, named oh my gosh, I'm blanking on my name. It'll come to me in a second. Nebula Miner,
Yes.
legendary Nebula Miner. He developed a plugin for Logic, this program, that will actually it's an analyzer that goes on top of the async serial analyzer, and it will decode the packets and tell you sort of what the job ID is, what the nonce is. And I'm kicking myself that I didn't get that set up for you for this live stream. That would be really cool to run. It's a fantastic tool. He did a fantastic job. It might take me a second to figure out how to get that set up for you. That's really helpful. That it's one of the cool things. Oh yes, Johnny, you're right. I'm gonna get to Johnny's question in a second here. One of the cool things you can do with this Logic software is you can make your own analyzers using Python that will run, and like if you have sort of an arbitrary packet format like we do here, it can run on your data and provide you with even more information. So I think that's what you're talking about, Jonathan.
Yes,
Is
correct. Exactly.
those custom analyzers. So yes, man, we're gonna have to have version 2 of this stream where we get into that because that's
For
really
sure.
cool. But so can you zoom in on one of those orange packets on channel 3 there,
Sure thing.
so we can see how many bytes are in it?
So I bet like
Set
the installation of
less
this
than a
extra
second.
tool is a little bit more complicated than to do the live in stream here.
Yeah, it is. It is. I would have to read. Nebula made a pretty cool tutorial on how to do it, and I would have to read that. Uh-oh.
Is that the name
But
enough?
nevertheless, the thing that we nevertheless, what we recorded here can be uploaded to the OSMU community, and we can do it on our own and figure out what's going on there.
Yes.
do
Before
it
we're done here, I
right
definitely want to
now.
go over how to save these files, and we can send them to because you can do all this analysis after the fact, right? You can save this file that contains all this data and do the analysis after the fact. But let's see, how many bytes do we have there? Is there 11? It kind of looks like 11 to me. I see
So
1, 2,
is
3, 4, 5.
that
How many are there?
separated by the dots you have here, or are you counting the line or the dots in that case?
The sort of gray squares up top, the 0x.
Oh,
How
got it.
many of
So
those
those.
are
Oh,
there?
yeah, obviously, yeah, okay.
Is there 11 of them?
Sorry, I'm having a bit time of having a good zoom with my laptop right now.
You need to zoom out a little bit
Yeah, yeah, but
so
it
that we
keeps
can see
zooming out too
those
much.
squares. I believe there are a little bit more than 11. 1, 2.
Okay, so
Let's see.
The zooming.
Yeah, the zooming on a laptop is a little bit hard.
yeah. So we do have 11.
Okay.
We do have 11. Okay. So as Johnny states, it's version rolling.
So yeah, Johnny's done a lot of work on digging into this, and he was one of the first people to crack this code, which is pretty awesome. But for a long time we didn't know what they were rolling, and we didn't know what the response looked like to indicate how version was rolled. And Johnny figured this out, which is pretty freaking cool. And yeah, 11 bytes means that they're doing version rolling, whereas before on like the S17 chips or the S9 chips, you'd see a 9-byte response, which doesn't include the version.
So
So
you heard it.
that's pretty
You heard
cool.
here first. There's going to be Bitaxe S19J Pro X.
Yeah. I mean, I think we could do it, right? The cool thing about the 1362s,
Correct. Yes.
the 1362 AK, it's a tiny little chip, and
Yeah.
it's super cheap, right? It's like half the price. So
3062? Which one is this?
out of the J Pro, it's the 1362 AK, I believe, is the one,
Well,
and
you
you
do
can get
have
them on AliExpress.
a few flavors of the 1362. You have the AA, AC, AJ, and AK that are popularized.
Yeah, you, Jonathan, you know a lot about this stuff, so we're gonna have to talk with you about that, about which one is sort of the right one to go with there. I remember a funny story. I remember when I was first starting this, and I was thinking I was going to do a Bitaxe with the 1397. I kind of started researching the chips and which one I should go with, because there's also a bunch of variants of that. And I
Yeah.
definitely immediately landed on the Decentral webpage, where you have quite a bit of information about that, which is really cool.
Yeah, that's the minor. Really, the 17 series for us has been the one that's forced us to figure out all that stuff. Because they had their issues. So first of all, understanding that issue I explained at the beginning of the stream with the copper plating took just that alone took quite a few months to fully understand and to be able to address properly. So obviously, yeah, there's a lot of digging that we did around the BM1397, and it's essentially how we also found out about the Bitaxe. I had one tech here that was looking at that project, and at the same time, I was looking, at more information about, because I'm always digging for more information, and I fell on your GitHub page, and it's both of those points together. So him being, our technician engineer here being really enthusiastic about the Bitaxe project, and us looking at the information that was provided there, and the two just merged together, and the rest is history.
So cool, right? That
By the
publishing this
way,
information.
guys, I'm sorry to interrupt you a little bit, just to clarify this, so for the viewership that we do have here, just to get a little bit more information about what do we exactly see here, like what do those bytes tell us? Do we have any sort of explanation for this, like to give them a little bit more about what we can figure out with this information that we now do see here?
Yeah. Maybe I can come up with a quick way to explain, generally how these miners work, right? So, if you're watching a geeky podcast like this, you might know some of this stuff, but I'll try and go over it quickly. Like, these miners contain hash boards that have big arrays of ASICs. That's the chips themselves. The chips themselves, all they can really do is SHA-256 hashes on Bitcoin block headers. So it's the job of the control board, which is sort of the controller for the whole miner. It's the job of the control board to send these block headers to the chips so that they can run SHA-256 on them. And it's the chip's job is to run SHA-256 over and over on these headers, incrementing the nonce and the version over and over and over and over and over, like a trillion times a second. And they're programmed where if they find, the whole goal of Bitcoin mining is to find a nonce that makes the hash of the block header less than a certain value, right? Like you can go read about that. That's the whole goal of Bitcoin mining. And so the chips are doing that, and they're looking for a nonce or that makes the hash less than a certain hash value. The output is like, it's actually less than. And they will report back to the control board when they have found a nonce that makes the hash less than, they call it the difficulty, less than this certain value. And so that's what you see there is you see on the red channel that Jonathan had on the screen, the trace that was in red, that's the block headers going from the control board to the chips so that they can start hashing. And then in orange, that's the response back from the chips. And of course, there's 110 chips on the board, or I don't know, there's a lot of chips on the JPro. And that's that orange trace is the response back of them saying, okay, I found a nonce and a version that makes the hash less than the difficulty. Here it is. It's sending it back to the control board so that then the control board, can take that and package it up and send it to the pool over Stratum so that you get paid for your hashing, essentially.
What I'm still wondering is, like, if I may interrupt you here for a second.
Sure.
With those hundreds of chips on the board, does each chip individually communicate with the hash board, with the control board, or do they actually communicate as a whole unit?
So they communicate as a whole unit. It's a little bit weird how they do it because there's so many chips. You can't have like a serial port for each chip. That would be like 100 serial ports. So what they do is they chain them all together and they're all on a serial bus. So each chip will respond itself. And that's why we see so many more of the responses in the yellow there. That's all the individual chips responding back, and they respond on this. It's more of a chain than a bus technically, but you can just think of it as the red is a command to all the chips saying, "Hey, work on this," and then the orange is each chip responding back, "Hey, I found something useful."
All right.
And
I think that's a pretty general and pretty good explanation.
I do believe you have a lot of that information that you just explained, Scott, on the registers page from the Bitaxe. So that page here I've just put on the screen. At least myself, I went and tried to. Obviously, I didn't understand everything, but I went over that documentation here, and it helped me conceptualize a lot of what we're going through right now. So I guess some of the viewers might want to head over that page. It's available on the GitHub in the BM1397 folder that you have. It's the registers document there.
Yeah, I might interrupt you here for a second. Let me put this in the chat. So if you're watching this on my channel, I put a link to the GitHub page from Skot in the chat so that you can view everything that is up there and just look out for all the documents that are in there. Everything is documented about this device and everything we're doing here.
So this data sheet that Jonathan's showing here is for the 1397. That's out of the S17. That page was made by the legendary Nebula miner.
So that's without the version rolling.
Yeah, that's without the version rolling. And so we have a version of this document that's for the 1366. That's the XP chip that we use in the Bitaxe Ultra. It's not finished yet. And then, of course, what you see on the screen here is for a whole different chip. It's the 1362. So it might be slightly different. So you can definitely go and look at those documents, but there's going to be some interpretation on each of those needed. Because again, we're reverse engineering this as we go. Normally when you work with a chip, like the manufacturer sends you a data sheet, but that's not the case here. So
Would be lovely, huh?
keeps it interesting. I wanted to, unless there's something else you think we should do, I wanted to go over how you can save these files and share them with everyone so that people can
Scott,
play along.
there's one good question for you, or maybe Jonathan want to answer this, but I believe you can answer this. Xcube was asking what actually is version rolling.
Oh, Scott is
yeah.
better suited than me to explain. So go ahead.
So version rolling it's actually kind of a hack, right? Like Satoshi came up with this whole idea, and it was Satoshi's concept that we would change the nonce, right? So when you're mining, you would change the nonce and then you'd hash again and check and see if it's good. And if not, you roll the nonce and check again. The problem is the nonce is only 32 bits long. Well, that's still like a billion something, a few billion nonces. Turns out miners are pretty quick these days, and they're doing trillions of hashes a second. So 32 bits doesn't actually like get you that many hashes before you need to send out new work. So what they're doing these days is they're doing version rolling. And so that's taking some other bits in the Bitcoin block header and changing those. So like you go through all 32 bits of nonce, and then you can change a bit in the version field. And that gives you 32 bits more nonce to roll. So it gives you more things to change in the block header before you hash it again. Nonce is just a number that gets incremented one at a time. Yeah, exactly. Yeah, nonce. It's so real quickly, like the way hashing works is it takes an input, you hash it, and you get a essentially a random number output. And the whole goal of Bitcoin mining is to see, is that random number output less than a certain value? And oftentimes it isn't. And so you need to change something on the input to get a new nonce output. And so nonce is the sort of 32 bits in the input that you're supposed to change. And so there's nothing that says you have to increment it by one, but that's the easiest thing to do. Yeah, hashing each nonce until you get a desired result. Exactly. And if you get a difficulty that is better than whatever it is now, like 65 trillion or something like that, then you've solved a block. Johnny says, for reference, BIP 0320 defines the section in the header for rolling version. Oh, wow, they do? Okay. Man, like, I always wonder, like, was Satoshi just being short-sighted and making nonce only 32 bits? Because it should have been obvious that we were going to... well, maybe it's not obvious, but it seems like you could predict that we would be hashing incredibly fast in the future, and that 32 bits wouldn't be enough, right? And
yeah, I'm personally also wondering about this. Like, would it be that difficult to change this to 64 bits, for example?
Right, 64 bits is an insanely large number. Like 64 bits would buy us a lot of time, right? If 64 bits isn't enough, I don't know. I can't recall off the top of my head what the number of bits, the largest number in 64 bits, but it's an enormous number. I don't want to be like Bill Gates and say that would be all we'd ever need, but it's close. It's definitely close. So 64 bits would have been pretty awesome.
Okay, so essentially it's 2 to the power of 64, which is like, well, okay, this integer is enormous.
It's real big, right? Like,
yeah.
Like 2 to the 32 is, okay, it's 4.2 billion, right? Okay, that's a big number, but 64 is got 19 zeros behind it. So that's, I don't know. I don't even know if there's a word for that number, but it's 1.8 with 19 zeros after it. So it's a very big number.
One thing I'd
Whereas,
add about version rolling, and that's and we already discussed, you and I, Scott, in the past. The first time I got aware of version rolling was due to ASIC boost. So back in 2017, 2018, when Bitmain had that end bleed vulnerability, it was also found that they had enabled and built what's required on the Antminer S9 to enable version rolling, but it was done covertly instead of being done overtly. And there was like this big drama back then where like Bitmain had tried to put this into a patent, but that was also released by some other developers. What I believe happened is it got patented before Bitmain could actually do it, so it protected ASIC boost, and so Bitmain couldn't keep it for themselves. But there was a big risk here where Bitmain tried to covertly enable this in their device, and there's also some suspicion that they had a special firmware that only them would use. And remember, back then, like about 80% of the hash rate was S9s plugged to the network, and a lot of the hashers had special deals with Bitmain because it would be the only way, to put your hands on hardware is to promise them that you will point your hash rate on their pool. So a lot of miners were, stuck back then, and so they would run their firmware on their pool. But in the background, it's very possible that Bitmain was actually using some hashes being done covertly through ASIC boost, through version rolling, to get some hashes for themselves.
yeah, that's like an amazing story. I wasn't, I mean, I was doing some mining, but I wasn't really paying attention to how it worked in detail back then. But it's a really interesting story. They had basically come up with a way to increase the efficiency of the chips by 25%, which is really big,
Oh yeah.
using this new technique called ASIC boost. And they didn't tell anyone, but they had enabled it in their chips.
But was it actually invented by them? Because what I was reading the last time I checked about ASIC boost, that this was invented by two individuals.
Yes, yeah, I think so it's not like a Bitcoin mining specific thing. It's actually a hashing, like a SHA-256 hashing, or just SHA hashing concept, like in cryptography or mathematics, that this could work. And so there's two guys, Sergio Lerner and Timo, I forget his last name, were the guys that published a paper on how this could be used for Bitcoin mining. And I don't actually know which happened first, the paper or the suspicion that Bitmain was doing it. But yeah, how do I explain this? So back then, this was the S9. The chip itself was not rolling version, but the chip itself could take 4 mid states. And so mid states are partially computed hashes. So like SHA-256 has a couple steps to it. And there's a step in the middle called a mid state. And so what they determined was that on the S9 chip, I think 1387, I forget the number.
S9 1387, yeah.
1397. 1390.
87.
Yeah, okay.
Yeah.
Yeah, 87. That's right. 87. They had determined that chip, you could load it up with 4 of these halfway computed hashes, and then it would then do those in parallel. So that's how they got that 25% efficiency, was to load it up with 4 mid states. And then I think a little bit later on the S17, I think it's also 4 mid states. But then when we got to these chips that roll version, they actually can do 8 mid states, I believe, at once, and they calculate those mid states themselves, like the chips do. And so, this is getting pretty in the weeds here, but it's pretty interesting, I think. The way you calculate these mid states is you roll version. So previously, the control board rolled version and calculated the mid states. Now the chips roll version and calculate the mid states.
So there's still that nice website I can just show in a sec on the screen.
Let's see. We got some more questions here. We're reaching a maximum of 1 to 3 nanometer chips. No, you can't go lower. Supposedly due to some issues. I don't know. Like, I've heard of less than 1 nanometer is possible. It's getting exponentially harder to do though. So certainly, it's slowing down. The efficiency gains because of smaller process size is slowing down.
Yeah, also, one thing that I quickly want to mention here is like I've heard it in the chat, like some people might think about like as soon as we do have a major breakpoint of quantum computing, that like the Bitcoin blockchain would no longer be sustainable or would no longer be a secure network. I don't think so, personally, for two reasons. The first one is, why the heck should someone use a quantum computer on the Bitcoin blockchain? Second one, it's way too expensive to use it for such a thing.
Yeah, it's hard to know. I mean, certainly Bitcoin isn't going to be the only thing impacted if we can, essentially reverse SHA-256 hashes brute force with quantum computers. Obviously, there's a lot of other cryptography, like all your credit card transactions, your HTTPS, anything we do security-wise uses a form of SHA encryption. I don't know. It's hard to say what's gonna happen in the future with this, right? We could fork Bitcoin with a quantum resistant algorithm, right? That's not impossible to think about.
Ooh.
Yeah, Ben's right. You can't reverse SHA-256, but what I was saying is you brute force it. If you can, if you have sort of one quantum computer with effectively like, multiple exahashes per second or whatever comes after that, then you could
Yeah, but the amount of time it would take is way too long, and the amount of power it would need, hilarious. I don't think so that this will come up in the next 50 years. Like, I'm not calling on the next 100 years, but in the next 50 years, I think we're far away from this. That this could even happen. Like, even if you would come up with scientific research on it and produce a quantum computer that would be able of doing such a thing, why should somebody of the team do such a thing of attacking the network of Bitcoin? Makes no sense.
I don't know. I actually don't know enough about this to intelligently talk about it, but it's now Ben says what's at risk is public keys. So there's a different algorithm for computing Bitcoin, public and private keys.
True.
SEC P256 different. It's like that elliptic curve cryptography. Yeah,
So
and then
if we want to go and save that signal, so maybe because I believe we're nearing the end of that part of the stream, and maybe we'll I obviously think we're going to need to come back and make a second part of this. But if we want to just close the loop on this one and make sure our viewers are able to go and repeat those steps and they're able to save their captures, what would be the next steps if we want to close this here?
Of course.
Yeah. Okay. So let's save this. Let's save this file. I think if you right click on that session 1 tab down below, I think you can just save it, right?
So right here, and then no. So maybe I guess file, save capture. Yeah.
Okay.
All right. Let me just, because I do have a lot of data on that computer, so I just want to make sure. Just a moment.
Yeah, maybe you can take those .sal files and drop them on the
Yeah, we'll do.
OSMU Discord for everyone to check out. I definitely would like to check them out. And for anyone else, you can go to Saleae, SALEAE.com, and you can download this logic software, and you can run it and open up these .sal files and run these analyzers on them and zoom in and out and play with it. Even if you don't have the logic analyzer itself, it'll just open up the files and it'll look exactly like Jonathan's screen there.
So you could take a look on what his miner did over the session that we recorded. That's pretty amazing. So I'd call this today's success of actually capturing what was happening between the control board and the hash board.
Yeah, I would too. This is really fantastic. And of course, this is only the tip of the iceberg of what's going on. There's all sorts of other communication going on here, right? Like changing hash frequency, changing sort of all the parameters of the chip, all interesting stuff to look at. And well, now that you know how to do this, Jonathan, I'm gonna hit you up for all sorts of details on this chip as we go forward here.
So the unit is still hashing in the meantime. We still have that board connected here. So for anybody that joined just recently, we do have an Antminer S19J Pro here. We've hooked up one of those sniffers from Open Source Miners United. You can thank the original author, which is Surveys a lot. He is the main contributor and also administrator over at Open Source Miners United. And he's made this open source, like everything that's made in that community, so you can become a mining hacker yourself. So what we're essentially doing, we have the control board here, we have that IO cable going to that sniffer. It's acting as a man in the middle, so we can go and connect the signals we want. We capture it on our little red box here, which is a logic analyzer. And that logic analyzer is connected to my laptop. The screen you can see right, I'm not set up like usually, but you can see the middle screen. And it's going back to the hashboard. So if we go and look at the interface, everything you've seen from that interface is actually captured from the actual miner. Right there. So you can see that this miner has been hashing the whole time. We have 57 minutes of uptime now. So essentially,
it's freaking amazing.
Yeah. Through this,
cool.
I can't wait to see what the community is gonna come up with. To me, it's already really enlightening, and from that simple basis, simply putting my hands on and being able to put the dots on the highs, as we say in French. I'm much more comfortable to go and start hacking more all around that stuff. So truly grateful for the time both of you have taken, and I truly believe we'll need a second session so we can go more in details into how to interpret the data, maybe also see with a Nebula Miner program on top of Logic software what we can achieve there, because that's it's still a bit foggy for me. But that being said, yeah, I think it's already really enlightening for me.
I agree. This has been awesome. Thanks to you guys. It was a great idea. We'll have to do it again.
Yeah, definitely. So I think we would call it for today. That's all what we could do for today, and taking a first glance on what's going on in here. So I think that's pretty amazing to have this first impression of what's going on between the logic board and the actual hash board. Yeah, I really appreciated that you both guys are here on this channel and that we are live streaming this. It's really amazing. So we definitely will talk about maybe a second session or anything else if we can figure out what to do with all the data that we got, or maybe we find anything major that we want to share with everybody.
Yeah, definitely for myself.
Good to me.
So prepare yourselves to have a lot of captures.
All right. So is there anything else that we need to do before we close up today's session?
Well, we've got a pretty cool Discord where we talk about this stuff kind of like all the time. So if you want more, check out Open Source Miners United Discord, OSMU. You can join there. And
I will post the link to this in the live chat.
Okay.
So there's a link to the OSMU Discord community. The
Cool.
invitation link. If you cannot find this, or if the live stream for whatever reason in a recap is not working, go to the website bitaxe.org. There you will find all the links to everything.
Yes, that's a good point. Yes, bitaxe.org. And of course, d-central.tech. That's D-Central's website. That Jonathan does amazing stuff. He's always coming out with crazy new stuff every single day. So go check out D-Central stuff and buy some gear from them. And yeah, let's hack this stuff.
Yeah, we have a warehouse full. You guys, you can see, help us getting it clean.
All right, that's pretty amazing. So I have to thank both of you for being here, and for all the viewers just staying up here and watching this. It was really amazing, taking a first glance and everything. And I think we will call it a day for today. Oh, do we?
Yeah, sounds good for me. Yeah,
Yep.
gotta go back to
all right. See
the
y'all later.
All right, it was fun talking to you both. Thanks for staying here, and thanks for all the viewers. I will close the stream right now.
Thank you.
All right, so I close the stream on my channel.
Cool.